going to go over these linear speed stuff questions, but I did get the tests and linear speed, what's the other one? Angular speed. Those are not on the unit test, so don't stress a whole lot about them. Arc length is on the test. Area of a sector is on the test. So those last two formulas that I gave you yesterday, not on the test, but since we went ahead and did it, like I definitely want to go over the questions that you have. It's not the worst thing to do in the world. What? What numbers did you say, Aaron? What did you say?
34 and 45.
All right, so let's look at 34 first. And 34 says, find the radian and degree measures of the central angle subtended by the given arc of length S on a circle radius R. Find the area of the sector determined by theta. So 34, that is a question. Those are things that are on the test for this chapter. Remember that the formula is S equals R times theta. And on this one, they give you S and they give you R, and they ask you to find theta. So you're just plugging that in. So on 34, it says S equals 3 feet and R equals 20 inches. So you just say 3 equals 20 times theta. You divide by 20, and that's a really weird angle measure.
Yeah,
but you can just leave it as 3/20ths. If it's an ending decimal, you can leave it, I mean, like that. I would just leave it as 3/20ths. It's just a weird answer, right?
I did have that. I guess I need a couple. Because I have 3 more.
Oh, and then it says find the degree measures, right? So this is in radians. And then if you would want to convert this to degrees, it's not going to be very pretty. 3/20ths, and to convert that to degrees, I would multiply by 180 divided by pi, and that's where I would definitely just type that in my calculator. Hey girls, nice of you to join us.
Angle doesn't really have any space because it's so box, but Mr. Wilkie's right there if you want to.
Yeah, here, if you want to track. Because track's way more important than math class.
Track's more important than well, I was running on calculator.
So I think I got 8.59 degrees for that answer. So again, make sure you read the directions of what it's asking, but to convert, you just multiply by 180 over pi. And then part B says find the area of the sector, and then that's just the other formula that you need to know for your test, which is 1/2 r squared theta. Is that true? Is that the formula I gave you yesterday? So the nice thing is, they give you the radius as, oh, I think I totally did this wrong, kids. You know what I did wrong on this? You can't have the S in feet and R in inches. That's not true. You see what I'm saying?
See, I got one myself.
All right, we're going backwards.
Way to go. No.
I need you to tell me this.
I did something. You missed it.
You have to have the same units. So do you want to work in feet or work in inches? So there's 36 inches, so we really should say that S is 36 inches and R is 20 inches, right? Like they need to be in the same units. That was a trick question. Did I give you 33 to do? That would have been much better to see how they're both in centimeters. So divide by 20. And that would be 9/5. Is that true? Still, I would just leave it as 9/5. That does work out to a nice terminating decimal if you want to give decimal. Again, that's in radians. So if you want to change that to degrees, which they ask you to, you're still going to do 180 over pi to get that angle in degrees, but you just have to make sure it's in the right units, which I did not do first. I think that's 103 points, I don't know, we'll do 2 decimals, 13 degrees if I did that correctly. Same process that we did the last time when I did it wrong, but we're in the right units now. Should get the same answer if you change them both to feet and how many feet 20 inches is. So, but nice thing is now that this is correct, Now I can plug this in up here. So the question is, it doesn't tell us what we have to give our units in. So since this only has a radius in it, do we want to just keep the radius as 20 inches? Keep it in inches here. 20 inches squared. And theta needs to be in radians, so we need to pick the 9/5 radians. And that would give us the area of that sector. And I think I got 360 square inches as my answer. Anybody else doing that on their calculator or just me? I got 3 seconds left, so I trust me. So again, of the formulas I gave you yesterday, the arc length and the area of a sector are the two that you need to know for quizzes and for tests. The angular velocity, linear velocity, not going to be on the test or quizzes. But Nick, did you have one of those end ones that you wanted to look at? So 45, just like that last example that we did, talks about a wheel of given radius is rotating at the indicated rate. Find the angular speed in radians per minute and find the linear speed in feet per minute. So on 45, they tell us that the radius is 5 inches and it's going 40 RPM. Remember that means revolutions per minute. So on part A, when it says find the angular velocity is just changing revolutions per minute into the units they want. And so they want you to find radians per minute. So all you have to do is change revolutions to radians. And we know that in 1 revolution of a circle, there are 2 pi radians. And it's already in minutes, so we don't even have to change it. And that gives us 80 pi radians per minute. That is the angular speed. And then part B is linear speed. And remember that linear speed is just taking r times that theta over time, or times your angular speed. So all you have to do for part B is take 5 times 80 pi. And again, it's in feet per minute. Oh, dang it. Tricky. Okay. So this is 5 inches times 80 pi radians per minute. And if you just do this, your answer is going to be in inches per minute. You with me on that? But they ask you for feet per minute, so I'm going to do one more conversion here, and I'm going to say in 1 foot there are 12 inches. And that's going to give you the right unit. So angular speed, linear speed, questions like 45, not on the unit test or the quizzes in this, so you don't have to stress too much about it. But even like the other one that we did with the units, you got to make sure your units line up and that you give it in the right thing. 5 times 80. So I'm guessing maybe if you didn't change inches to feet and you checked your answer in the back of the book, that's probably why your answer didn't match up. Did they give it as a decimal, do you know, in the back of the book? It's with pi or without pi, like they multiplied pi again. So times pi, 104.7, is that the answer? Like if you multiply this out, you get 104.7 feet per minute. And again, I just got that test from Ivy Tech, so I didn't know that this wasn't on the test, which is why I taught it. I teach this in pre-cal, so that's why I thought I should teach it. This is not on the test, but ones like 33 are on the test. If you would have been and relax, you would have heard. Or you can leave pi in it, I don't care. Right, like it's like 33.33 pi. I would like to do the last slide. I think there's only 1 slide of notes left that we didn't do yesterday. Is that true? Maybe 2 slides. Maybe. Maybe it's right here. Oh yeah, right here. I think this is where we are. And this is really something you can do on your calculator. It's just some notation. Sometimes in the books they'll throw stuff using degrees, minutes, and seconds instead of decimals. And it's just a more accurate way than using decimals. And if you are going to ever fly a plane, or you are sailing, or you're lost in the ocean and you want someone to find you, the way that they find location, that they do latitude, longitude, is they don't do decimals, they do degrees, minutes, seconds. And so if you've ever seen something like this, like 132 degrees, 42, whatever, 70, not 7, let's do 7. Like latitude, longitude, if you ever look on your phone and you try to find something, like it gives stuff like this. Sometimes it'll be like west or east or north or south, latitude, longitude. And it's just a way of being more specific to find someone. And so in one revolution of a circle is 360 degrees. So that means in 1/360th of a revolution, that would just be 1 degree. And then you can take 1 degree and you can break it into smaller units. So really hard for me to draw 1 degree, but think about 1 degree would be like super, super tiny. That 1 degree is broken up into 60 minutes. And the symbol for minutes is kind of like a little like apostrophe prime, which means you can take that 1 degree and you can break it up into 60 minutes. And then you can take each one of those minutes, think about there's 60 of them in between here. You can take each one of those and that breaks up 1 minute equals 60 seconds, which is 2 little marks. So if you want to write minute here and second here. You can do this by doing the conversion like we just did with the feet and the miles and the radians and the revolutions. You can set up a little conversion thing, but the really cool thing is there's a button on all the calculators that will convert from degrees, minutes, seconds to decimals and the other way around. So this is not a huge part of this class, but I just want to show it to you and show you how to use the calculator. So if you don't have a calculator, let me give you one. So on my, if they give it to you as a decimal, you can just type that in, 125.17 on your calculator. And then on my calculators, it's the button right below delete, like you'll see the little degree, minute, second sign. And on my calculators, if you hit that button, there's a lot of options. There's a degree, there's a minute, there's a second. You need to arrow over, all the way over till you see this, DMS, which means degrees, minutes, seconds. And if you have this and you wanted to convert it to degrees, minutes, seconds, you just hit that button. Now hit enter and it should tell you, maybe you have to enter twice, that that is the same as 125 degrees, 10 minutes, and 12 seconds. Anybody need help with that? Yes. I didn't see it on there, but here's what happens sometimes in trig books like this. Later on, this will show up. Like they'll ask another problem about trig, but it'll be in degrees, minutes, seconds. So you just need to know how to convert it. Like it's really a simple calculator thing if you know how to use the calculator. Probably. You just have to look for DMS button. I don't know. Oh yeah, I can look at it. If they give it to you in degrees, minutes, seconds, and you want to go back to decimals, you have to just use that degree, minute, second. So you actually type in 315, and then you hit the degree button. Like you go to the degree, minute, second button, and you hit it, and then you type 48, and you type in the minute button, and 3, and you type in the second button, and you just hit enter, and it should give it back to you as a decimal. And if we just round to the nearest hundredth, like it says, you get 0.80. And so that's why degrees, minutes, seconds are better for navigation, because you don't want to be giving up 12 decimal points when you can give off degree, minute, second. And when they're looking for someone that's lost, being able to find degrees, minute, second to find the exact location, or if someone's dropping a bomb somewhere, you want to make sure you're dropping it in the exact right location. Not that you should be dropping bombs anytime soon, but that's why they use this. It's kind of, I mean, it really is a real life application to being able to do degrees, minutes, seconds, but are they computing it by hand? No, probably not, because you can just use your calculator, but just so you're aware of They really should say 3:15.
Oh, okay, I was like,
This part should just be the decimal part. I just wrote down the wrong number. All right, that's the only thing I didn't get to yesterday. I want to talk about those angles, like being able to break up radians and knowing what they are, but I think I'm just going to wait until everyone else gets back, since everyone in here has had pre-cal before. I don't want to do that stuff without them. So tonight's homework, if you've done the other homework, should be pretty short, because the only thing we didn't do yesterday was 23 through 26, and they're all degree minute second problems, which means you're in here until 124, which is 12 minutes. 4 questions. You can use your calculator to do degrees minute seconds. So you definitely add that on to yesterday's homework. Tomorrow, I will check 6-1 homework, because we've done 6-1 day 1 and day 2 now. So tomorrow I will check it. We're not going to turn it in, but I'm going to check that you did it and give you points for it. And then we'll move on to 6-2 tomorrow. Our first quiz is after 6-2, which we're going to spend a couple 3 days on. But definitely we should have a quiz, our first quiz next week sometime. Okay?